A rare star stream outside the Milky Way just gave astronomers a new way to weigh dark matter in distant galaxies. This is Fascinating Frontiers, episode 161. Astronomers have identified a coherent stream of stars in a distant galaxy that has no counterpart yet observed beyond the Milky Way. The stream's narrow morphology and velocity gradient allow reconstruction of the host galaxy's gravitational potential at large radii. Because the stars are dynamically cold, small perturbations from dark matter subhalos would produce observable gaps or spurs. The discovery therefore supplies a new probe for the clumpiness of dark matter on galactic scales. Follow-up imaging with larger telescopes will search for additional stream members and refine the mass model. Wide-field imaging and multi-object spectroscopy will map the stream's full extent and velocity field, allowing reconstruction of the host galaxy's potential at large radii. The same dataset can test whether the stream's progenitor was a globular cluster or a dwarf galaxy. Picture a ribbon of stars so thin that if it were laid across North America, it would span barely the width of a highway, yet stretch from New York to Los Angeles without a single kink visible from orbit. That is the scale of coherence astronomers now see in a stellar stream inside a galaxy millions of light years away. The stream formed when a small cluster of stars was torn apart by the host galaxy's gravity, leaving its members on nearly identical orbits that slowly shear apart over billions of years. Because those orbits feel every passing mass, a dark matter subhalo only 1,000,000 times the Sun's mass can punch a visible notch in the ribbon. Telescopes record the notch's size and location. Models then convert the geometry into a mass for the invisible perturber. The surprising number is that these subhalos are predicted to be far more abundant than the visible dwarf galaxies we actually detect. Yet the stream data are beginning to show exactly that excess population. The lingering mystery is why some streams remain razor straight while others display multiple gaps. On a different note, a Tasmanian observer operating from a Midlands observatory has confirmed multiple new exoplanets through sustained ground-based photometry and radial velocity follow-up. The work relies on modest aperture telescopes and careful scheduling to catch transit signals that larger surveys missed. Data reduction included custom detrending to remove atmospheric and instrumental noise, allowing detection of shallow dips. The discoveries add to the census of planets around nearby stars and will feed into future atmospheric characterization campaigns. Next steps include additional radial velocity measurements to pin down masses and orbital eccentricities. Shifting focus, Indian officials outlined plans to expand launch services, satellite manufacturing, and data sharing agreements with international agencies and commercial operators. The strategy centers on the existing launch infrastructure at Sriharikota and new private sector facilities under development. Discussions include joint Earth observation constellations and technology transfers for propulsion components. Government statements emphasize regulatory streamlining to shorten approval timelines for foreign payloads. Follow-on negotiations are expected at upcoming bilateral space forums. The SpaceMaRS initiative is developing processes to produce high-value materials and components aboard future orbital platforms. Researchers are testing microgravity effects on alloy solidification and polymer curing using parabolic flight and suborbital test flights. The program aims to reduce launch mass by fabricating replacement parts and specialized optics on demand. Early results show improved crystal uniformity in certain semiconductor compounds compared with terrestrial production. The next phase will integrate prototype hardware into a commercial space station module for longer duration trials. JWST observations have revealed a gas giant planet with roughly twice Jupiter's mass orbiting a young star. The detection combined direct imaging and spectroscopy to measure the object's thermal emission and atmospheric composition. Early spectra indicate elevated levels of carbon-bearing molecules, consistent with formation beyond the water-ice line. The planet's separation and luminosity suggest it is still contracting and cooling. Additional epochs will track orbital motion and search for variability in cloud features. Engineers at MIT are quantifying how wall geometry, lighting spectra, and circulation paths influence stress and social cohesion in confined spacecraft volumes. The team built full-scale mock-ups and recorded physiological and psychological metrics during multi-week isolation trials. Results show that curved transition zones and tunable daylight spectrum lighting measurably reduce reported loneliness scores. The work separates requirements for short-duration survival habitats from those needed for multi-year missions. The dataset will inform interior layouts for Artemis surface habitats and future Mars transit vehicles. Researchers have traced periodic radio pulses from binary systems containing a white dwarf and an M dwarf companion. The emission mechanism appears analogous to the electrodynamic interaction between Jupiter and Io, with the white dwarf's magnetic field accelerating electrons along field lines that thread the M dwarf. Timing of the bursts matches the orbital period, confirming the interaction geometry. The systems offer nearby laboratories for studying magnetic reconnection and particle acceleration under extreme field strengths. Continued monitoring will test whether the radial luminosity scales with orbital separation as predicted. The U.S. Space Force awarded $60 million across 5 firms to demonstrate cross-link compatibility with the SpaceX data backbone. Each company will deliver prototype terminals and conduct on-orbit demonstrations of dynamic routing and handover protocols. The effort targets resilient multi-vendor command and data paths for future proliferated architectures. Ground integration tests begin later this year, with flight demonstrations scheduled for 2027. Success metrics include sustained data rates and latency under simulated jamming conditions. New spectroscopic surveys of the most distant known galaxies show that the elemental building blocks for rocky planets and water were already abundant when the universe was less than 1 billion years old. The measurements rely on rest frame ultraviolet lines redshifted into the near-infrared, accessible to current large telescopes. The early enrichment implies that core collapse supernovae from the first stellar generation dispersed metals on short timescales. The finding revises models that assumed a prolonged delay before planet formation could begin. Next analyses will map metallicity gradients within individual high redshift systems. A proposed ground-based array of 900 small telescopes would collect enough photons during a single transit to extract an Earth-like exoplanet's transmission spectrum. The design distributes collecting area across many apertures to reduce cost and enable rapid replication. Simulations show the combined signal-to-noise would suffice to detect ozone and water vapor features at 10 parts per million precision. The array would target stars within 50 parsecs that host planets in the habitable zone. Site selection studies are underway to minimize atmospheric interference. Mike Fincke has concluded 3 decades of NASA service that included 2 long-duration expeditions to the International Space Station and leadership of the Commercial Crew Branch. He logged more than 380 days in orbit and commanded Expedition 18 and Expedition 36. Fincke also contributed to the development of commercial crew vehicle certification procedures. His retirement leaves open the chief of the Astronaut Office's Commercial Crew Branch position. NASA has not yet named a successor. Radio and X-ray observations reveal a jet extending 300,000 light-years from a distant supermassive black hole. The jet's length implies sustained energy output over at least several million years. Magnetic field measurements along the jet suggest ongoing particle reacceleration far from the central engine. The source offers a laboratory for studying feedback processes that regulate galaxy growth. Deeper radio imaging will search for older, fainter lobes that could trace earlier activity cycles. Neutron and X-ray tomography of a Martian meteorite has located macroscopic hydrogen-rich regions that survive terrestrial weathering. The distribution indicates water-rock reactions occurred early in Martian history, before the rock was ejected. The findings constrain the duration and extent of near-surface aqueous environments on Mars. Parallel isotopic analyses will test whether the water matches the composition inferred from rover measurements. Additional meteorites are now being scanned with the same non-destructive techniques. Northrop Grumman is repurposing environmental control and thermal management systems originally developed for the cancelled Hallow Lunar Station module. The hardware will support the Artemis surface habitat architecture now under study. Engineers have begun re-qualifying components for longer surface stay durations and lunar dust exposure. The move preserves prior investment while aligning with current lunar architecture decisions. Integration tests are planned at NASA's Marshall Space Flight Center. A NIAC-funded concept would release fleets of sunlight-levitated microscopic sensors into the 30 to 100 kilometer altitude band to record long-duration wind and temperature profiles. Each tracer would remain aloft for weeks to months, far exceeding the minutes-long data arcs from sounding rockets. The sensors transmit position and local state via low-power radio links to ground stations or orbiting relays. The approach targets the poorly sampled ignorosphere that influences global circulation and space weather coupling. Prototype release mechanisms are scheduled for suborbital validation flights. Keep an eye on the prototype hardware tests for the 900 telescope array as site studies advance. That's Fascinating Frontiers for today. If you enjoyed this, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for exploring with me, and I'll see you next time. And if you'd rather watch than listen, find us on YouTube at NARA Network. Links in the show notes. And before you go, this show is part of the NARA Network, a family of daily podcasts on tech, science, and markets. Each one a short, sharp briefing you can finish on the commute. If today earned its place in your feed, here's your next listen. SpaceX Daily, the daily companion for following SpaceX as a public company, from Starship to the stock ticker. Find every show free at naranetwork.com. The age of AI puts real builders on the phone with an AI host. Apply at naranetwork.com, Age of AI apply. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.
Drifting softly